Okay, now the next point is moving coil galvanometer. Initially, what is the galvanometer? Galvanometer is the device which detects the presence of current which is flowing. So it only check whether the current is present in the circuit or not. So what is the construction of this moving coil galvanometer? There are two types of the moving coil galvanometer. First is the pivoted type and second is the suspended type. So here we can see the suspended type. So there is a galvanometer which is suspended type galvanometer. So here there is a rectangular coil. The name of the coil is PQRS. This coil is suspended by means of a wire. So one end of the coil is connected to the fixed rigid support and second end is given to the spring. This is called helical spring. And also this coil is placed in two strong pole pieces of the horseshoe magnet. And also one mirror is connected along the wire which is used to give the deflection of the current flowing through the coil. Now when the current starts flowing through the coil, then due to the current flowing through the coil, it produces the magnetic field. Also one more magnetic field is produced by the two strong pole pieces of the magnet. So there are two magnetic fields. Due to these two magnetic fields, the coil experiences a torque. So the magnitude of that torque is given by, it is NIAB. The magnitude of that torque is given by NIAB. So this is equation 1. When the coil starts deflecting due to the torque experience on the coil starts deflecting. Due to that deflection, this spring gets twisted, and due to this twisting of the spring, the torque which produces into the, or restoring torque is produces into the spring, which tried to get the coil into its original position. It tries to give the coil its original position by again releasing the spring. So the torque which is stored in the spring is directly proportional to deflection of the coil. If the coil gets maximum deflected, then spring gets more twisted. So the torque, restoring torque in the spring is directly proportional to deflection of the coil. So here if you remove the proportionality sign, then we introduce constant. The constant is K. This is called torsional constant, or it is also called as twist constant. Suppose we consider this is equation number 2. From equation 1 and 2, we concluded that the left side is same, so we can compare the right side. If you compare the right side, then K phi is equals to NIAB. So if you are sending the K to the right side, then NBA upon K outside the bracket is I. The terms present in the bracket all are constant. Number of turns, magnetic field or the strength of the magnetic field, magnetic induction, area of the coil, torsional constant, all terms present in the bracket are constant. So we can say that the magnet and the deflection of the coil is directly proportional to current. If the maximum current is flowing through the coil, then the coil gets maximum deflection. If the minimum current is flowing through the coil, then coil gives minimum deflection. So deflection is directly proportional to current. This is the simple principle of the moving coil galvanometer. So this is one important topic. After that we have one more topic, that is the magnetic moment, magnetic dipole moment and electric dipole moment. What is magnetic dipole moment? I have considered one magnet. Then magnet have two different pole. One is the north pole, second is the south pole. Here M plus M minus M. This is called pole strength. What is the pole strength? The strength of the magnetic field at the pole is called pole strength. At north pole, the strength of the magnetic field, that is a pole strength, is denoted by plus M, and at south pole the pole strength is denoted by minus M. So pole strength is the strength of the magnetic field at the pole, and distance between these two poles, north and south pole, is denoted by 2L. This 2L is called magnetic length. In that case, how can you define the magnetic dipole moment? magnetic dipole moment capital M is given by, it is a product of pole strength and magnetic length. It is a product of pole strength and magnetic length. But suppose the magnetic field is produced by using a current carrying coil. If the current starts flowing through the coil, then in that case it produces the magnetic field. In that case, the magnetic moment is given by NIA. So what is N? Number of turns of the coil. If you are wrapped the wire on the coil, then that number of turns is given by N. I is the current flowing through the coil and A is the area of the coil. So magnetic moment for a current carrying coil is given by NIA and magnetic moment for magnet is given by M dot 2L. Then what is the, suppose the current carrying coil is placed in uniform magnetic field. So this coil, suppose we are placing in uniform magnetic field, then in that case it experiences torque. The torque is given by mb sin theta. Here M is the magnetic dipole moment, B is the strength of the magnetic field. It is called magnetic induction. So we can consider here, if you consider in vector form, then torque is equals to M cross B. So there is a cross product. In terms of magnitude, we can consider sin theta. Now next, this is about the magnetic dipole moment. So this where M is NIA, if this torque is experienced by the coil and current flowing through the coil which produces the magnetic field. In terms of the coil, the value of M is NIA. Then same torque experienced by the magnet when the magnet is placed in the magnetic field. Then in that case the value of M is M dot 2L. So the difference is, here the M is magnetic dipole moment by the magnet. Here M is magnetic dipole moment by the coil. Electric dipole moment is P is equals to Q cross 2L. What is Q? What is dipole? Two charges, positive charge and negative charge, separated by small distance, finite distance, forms the dipole. Here the magnitude of charge is Q, positive charge, negative charge, but the magnitude is only Q and distance between the two charges is 2L. So what is electric dipole moment? It is a product of magnitude of one charge and distance between the two charges. It is called electric dipole moment. If suppose this dipole is placed in uniform electric field, if the dipole is placed in uniform electric field, then the torque experienced by the dipole is given by P cross product of E. P is electric dipole moment and E is electric field intensity. Strength of the electric field is given by E. It is called electric field intensity.